Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, for this video, in this video, we will discuss another problem, sample problem from the fundamental of physics. It's about floating buoyancy and density. Let's jump to the question quickly. In this figure 14.11, figure 1411. This is the figure I have screenshotted. A block of density rho equal to 800 kilogram. The density is 800 kilogram per meter cube. Floats face down in a fluid of density rho f equal to 1,200 kilogram per meter cubic. The block has height h, which is h is equal to 6.0 centimeter. By what depth h is the block submerged? B, A, by what depth h is the block submerged? And B, if the block is held fully submerged and then released, what is the magnitude of its acceleration? Okay, from this question, we get some information. Okay, let's use the information that we got. Information. Let's list. The first one is the density of the block. We call it rho is equal to 800 kilogram per meter cubic. And then we have the density of the fluid with the density rho f one equal to 1,200 kilogram per meter cubic. The block has height 6.0 centimeter. So the height of the block is 6.0 centimeter, or we could change it to meter. It is equal to 6.0 times 10 to the power of minus 2 meter. Okay, so the first question that was being asked for this question is by what depth h is the block submerged. So this is the figure. We need to figure out the small h. The big h, or the height of the block, is 6.0. Now we would need to determine how much is the h, the little h, the value of the little h. The little h is uh, is actually, if you see the figure that been showed in the question, it is the type of the part of the block that was submerged in the water. So we need to determine the value of it using the Archimedes Archimedes law. Okay, so we could figure out h using Archimedes law. Okay, so maybe let's try to solve this equation. Let's start from the A part, section A part. Okay, for the A part. Okay, for the A, because this block is in the buoyant, in the floating condition, in a floating condition. Okay, so because of this block is in floating condition, so the Archimedes force, or the floating force, the buoyancy of the block will be equal to the weight of the block. So I could state it here that Fa, or the Archimedes force, will be equal to W, which is the weight of the force, the weight of the block. Fa is, we could uh, derive it. We could change this equation to rho of the fluids times the volume that has been submerged times G, equal to rho of the block, the block, times the total volume times G. We could erase G from this equation, so we could get rho F times F phi S is equal to rho phi. So how do we find H in this equation? So The volume, the total volume, we know the total volume is just the same as the area of this block times its age, its height. So the volume of it is just the same as the area of this block times the height of the block, the total height of the block, which is big H. Okay, so this is for the V, and for the Vs, or the volume that been submerged in the fluid, is just the same as A times the h, the little h, right? The volume of this area, of this submerged area, is the volume of this submerged region is just the same as its area times the height, which is little h. So we could change it to rho f times a times h, little h, equal to rho times a times big H. So we could erase A from these equations, and then we get rho F times little h equal to rho times capital H. So to find H, we could get the equation rho times capital H divided by rho F, which is, we could get it, rho is 800 times 6 to the power of minus, oh no, 6 to the power of minus 2 divided by 1200. Okay, and then we could simplify this to 2 times 2, it's 2, it's 3, and then we could derive this, we could erase this 2 3 6 divided by 3 is 2, 2 times 2 is 4, 4 times to the power of minus 2 meter, and we could change it to centimeter, which is 4.0 centimeter. Okay, then we get the h, the value of h. So the depth h when the block is submerged is 4.0 centimeter. Okay, I think that's clear. Okay, for the second question, let's see. If the block is held fully submerged and then released, what is the magnitude of its acceleration? Okay, the key word for this question is the block is held fully submerged. Fully submerged mean that the volume that's been submerged to the fluid is equal to the big V, or the total volume. Because of what? Because the region that is submerged at the fluid is just the same as the total volume of the fluid, because the block was fully submerged. Okay, so the Vs will equal to V, the total volume of this block. Okay, that is one perception that we know that we need to know. Okay, so let's continue reading the question. Then released, what is the magnitude of the acceleration? Okay, the magnitude of the acceleration, it means we need to find the value of the acceleration. We could use Newton's second law here, which is sigma f is equal to m times a. So sigma f, we need to determine what is the force that acting upon this object, upon this block. Well, of course, there is a force, the weight force or the gravitational force from this block, and then we have the buoyancy or the Archimedes force. Okay, so let's assume if upward, if the force going upward, it's positive. If going downward, it's negative. So the Fa, so if we write it here, the sigma F in the system is Fa minus W equal to M times A. Now we know the Fa is equal to the rho of the fluids times the volume of the block that's submerged. But of course, because the volume that's submerged at the fluid is equal to the total volume of the block, so we just use v, okay, in this equation, times g minus rho of the block times volume, total volume, times g is equal to ma. M, don't forget m here. M, what we use, m is here. This is the mass of the block. So the m that we use here is the mass of the block. Now we know that rho is equal to m times v, and we could know that we could took a conclusion that m is equal to rho times v, the total volume times the density of it. So we could change the equation to rho v times a. Now we could change this rho times v times g to here, to the right, and then it will be rho f times v times g is equal to rho f times a plus rho v, I'm sorry, rho v, rho v, yeah, v, not f, v times g. Now uh we could find, I'm sorry, I think there I make a mistake, uh just make it, just let this equation just like this, just let it like this. Now, because what we want to search is the magnitude of the a, so let's just move this rho v to the left side. So we could get that rho v times g minus rho v times g divided by rho v. Now we could change this equation to rho v times vg per rho v minus rho times v times g per rho v. Yeah, it's just the same, right? Right. So the a will be equal to v. We could we could eliminate this. We could eliminate rho v and rho v and this one, and then we get rho v times g per rho minus g. Yeah, see this is the magnitude of the a, and then just move it here, and then we could go out the g. We could uh go out the g. We could insert we could outsert the g from this equation, so the g will be g times rho v per rho minus 1. Yeah, we could outsert this g, okay, and then let's just insert the data that we had. G is equal to 9.8 times rho v, which is 1200, right? Yeah, 1200, 1200 per 100 minus 1, and then we get a is equal to 9.8. This is 3.3 divided by 2 minus 1, and it will become 9.8 times half, 1 divided by 2, or half, 0.5. So we get 4.9 meter per second square. This is the acceleration of the block. Okay. Okay, I think that's all for this video. Hope you can understand my discussion and my steps to solve this question. Thank you. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.